Good morning. My name is Nora KACIMI. I'm from National Polytechnic School. My presentation entitled Maximum Power Point Tracking using Neural Network Integral Backstepping Sliding Mode Control in PV solar systems. So, as you know, the renewable energy is being used around the world. The solar photovoltaic is envisaged to be one of the key source of the future energy. Variable condition, environment condition cause the change in maximum power and produce the low efficiency of PV systems. To increase this efficiency, a maximum power point tracking algorithm is developed to harvest the maximum power. To operate the PV system at the maximum power point for any climatic condition, there are many MPPT methods in literature. However, conventional MPPT presents some drawbacks such as large oscillation and low tracking speed. Recently, several intelligent techniques have been introduced in order to extend the performance. In this context, these people proposed a new hybrid MPPT algorithm using neural network integral backstepping sliding mode control. The neural network is used to predict the operation PV current, then integral backstepping sliding mode is employed in order to maintain the PV current corresponding to the reference, as shown in Figure 1. Artificial neural network is a computational model inspired by the biological neural network. It has three layers: input layer, one or more hidden layer, and output layer. In neural network, the input layer receives divided information which analyzed in hidden layer. Then the results provided by the output layer at the end of the analysis. Three-layer neural network is chosen in this paper. The two input layers, which are the current and the voltage, and the output is the current at the maximum power. To training the neural network, input-output datasets were collected using the PV module and variables of different irradiation and temperature. The measurements were collected for each power and voltage obtained from the mathematical module and calculated the correspondence of the MPPT current value for each given radiation and temperature. In order to force the PV system to tracking the maximum power point tracking with a minimal start error and reduce the throttling phenomenon, the integral backstepping sliding mode structure is proposed. The dynamic of boost converter is present in the equation 1. The error is the difference between the E-reference providing the neural network and the actual E-PV. The output of the after using developed some questions. Output controller is given by equation 2. To validate the performance of proposed system is implemented in MATLAB simulating as shown in Figure 2. The PV characteristic output under any four variable irradiation is shown in Figure 3. The red circle represents the position of MPP at the corresponding irradiation. From Figure 4, it is clearly observed the proposed hybrid MPPT tracking the maximum power point and the standard condition and the variable condition. The irradiance is beginning at 1000, then decreasing to 600 at time 0.6 seconds, then increasing to 1000 at time 1.2 second. The results is shown in figure 5. In order to track the maximum power point, an improving control schema of PV system has been developed in this paper. The MPPT is based on neural network and an integral back-stepping sliding mode to regulate the uncertain PV current and control the boost converter. The obtained results show the high performance of proposed hybrid MPPT. Thank you so much for your attention. Thank you so much for your attention.